Okay, so we're going to learn geometric sequences. Before we start, everybody say hi to Lizzie.
Hi, Lizzie.
Thank you, Elijah. Very helpful. So we're going to talk about geometric sequences. And there are two types of sequences that you need to be familiar with. One of them is geometric. And the other is arithmetic. So I think the easiest way to explain what these are is to give you an example. A sequence is just a list of numbers. There's a sequence of numbers: 256, 128, 64, 32. The first thing that we check whenever we have a sequence is this a geometric sequence? In order for something to be a geometric sequence, the ratio from one term to the next has to be the same. In other words, my first sequence here, my first pair of numbers, is from 256 to 128. The way I figure out what the ratio is I take the 128 and divide by 256, and I get
0.5.
or 1/2, because 128 is half of 256. Okay, then we go to the next pair, 128 and 64. So we do 64 over 128, which is
0.5.
also a half, because 64 is half of 128. Is 32 half of 64?
Yes.
Yes. So now that we know what the ratio is, it's kind of easy to see by looking at the numbers. We're cutting them in half every time. 256 cut in half was 128. 128 cut in half was 64. 64 cut in half is 32. Since the ratio is constant, meaning it's 1/2 every time, this is a geometric sequence.
Bless you. You're welcome.
So our definition of geometric sequence would be the ratio is constant.
Did it freeze?
Hope not. Okay, let's try another one. It's not, so Andrew said it doesn't go down by a half. He's right. But just because it's not a half doesn't mean it isn't geometric. Could be a different ratio. So 4 to 9 right there. I do 9 over 4.
Adds by 4.
That's 2 and a fourth, 2.25, 2 and a fourth, right?
Mm-hmm.
Let's see the next one. It's 9 to 12. So I would do 12 over 9, which reduces to 1 1/3. Uh-oh. There's not really any reason to go farther because I know they're not the same, but I will just for the sake of completeness. 16 over 12. That's also 4/3, or 1 1/3. So two of them are the same, but not all of them. So since the ratio is not constant, This is not a geometric sequence. If it's not geometric, the next step would be to check and see, is it arithmetic? Arithmetic has nothing to do with ratios. Arithmetic means, is it going up by this or down by the same amount every time? So an example of an arithmetic sequence would be 2, 4, 6, 8, 10. It's going up by 2 every time. Another one might be 5, 10, 15, 20, 25, going up by
5.
And it would also be correct to say that an arithmetic sequence was 100, 90, 80, 70, 60. It's going down by 10, the same amount every time. So once we figure out it's not geometric, our next question becomes, is that same sequence arithmetic? Okay, so to get from 4 to 9, what am I doing?
You're adding 5.
I added 5. To get from 9 to 12,
3.
uh-oh. To get from 12 to 16,
4.
none of those are the same. So since the difference is not constant, this is not an arithmetic sequence. There might be other kinds of sequences that this is. This might fit into the category of another kind of sequence, but the only two we're going to learn are geometric and arithmetic, so if it's not either one of those, you're done with the problem. You just say it's not a sequence. It might be some kind of crazy sequence that we're not going to learn, but for our purposes, it's not one. Okay, so let me give you, scroll down just a little bit there. Let me give you 3 to practice on your own.
Yay.
Just put these in your notes. I'm going to give you 3 of them. 1, 3, 9, 27. That'll be the first one. Sometimes you'll see dots on the end saying the sequence keeps going, which is fine.
Will that affect it?
No. No. You can only make a decision with the information you have. And then okay, take just a minute or two. See if you can figure that out. All you're going to write is arithmetic, geometric, or none. Is there one of these sequences that you think is easiest to find?
The first one.
Arithmetic, geometric, or none? Which one do you think is easiest to find? You think geometric's easiest when you find the ratio?
I think arithmetic.
You think arithmetic's easiest? Why do you think arithmetic's easiest?
Because you can look at the numbers, well, you can figure it out faster. You can recognize addition but faster than you can recognize division or multiplication.
I agree with Ellie. It's a lot easier to see if something's adding or subtracting the same amount than to see if something's multiplying or dividing the same amount.
Do you think that would change if we were taught how to divide and multiply first?
I don't think we would
No. No, I don't think so, because
does include adding.
even if you were taught multiplication and division first, I think addition and subtraction is still easier for your brain to do.
It's simpler.
If I said do 12 plus 4, you could figure that out a lot faster than if I said do 12 times 4.
Longer for that addition and that multiplication.
I don't mind school.
Can you come check mine, Mr. Taylor? Can you come check mine?
Yes, ma'am, I'm coming. They're one or the other.
Can they be both?
Excuse me. Oh, that's a good question. Yes, ma'am. Okay, sounds good. Yes, I will. Elijah, can you go open the door for Harley, please? I like your first two, but not the last one. If those aren't the same, the answer is none. So the question was, could it be arithmetic and geometric at the same time? The way you would answer that question is there something you could add over and over again that would have the same effect on the number as something you multiply over and over again? I can't think of it. 2 was the first one I thought of, but I don't know that 2 works. If you multiply by 1, though, the number wouldn't change. Your sequence would be, maybe that's an example. If your sequence, and I'm using like the largest air quotes ever here, if your sequence was 5, 5, 5, 5, 5, 5, then you are adding 0 every time, so that's constant, and you are multiplying by 1 every time, so that's constant. So Peyton, you may have figured out the one and only case, but I don't know that mathematicians would agree with us that 5, 5, 5, 5, 5, 5, 5 was a arithmetic sequence. We might have to argue with them about that.
0, 0, 0, 0, 0.
Argue with the Lord of Math. Oh, he lives in a temple. You don't find him, he finds you. I don't know.
He's the one that
Lord of Math, come to
Okay, so Ellie's hypothesis was that the arithmetic sequence was the easiest to find, and I agree with her hypothesis. But if she's right, that means when we look at all 3 of these, we should be able to very quickly find the one that is going up or down by the same amount every time. Which one's going up or down by the same amount every time?
The second?
The second one. Negative 20, negative 15, negative 10, negative 5. What is it changing by?
5.
5 every time is going up or down?
No, up.
It's going up,
How is it
yeah.
going up?
Because negative 15 is higher than negative 20.
Because it's closer to 1.
So this one is arithmetic,
Can I say the first
and our pattern is that we are adding 5 every time. Okay, Maddie, you got some ideas on the first one?
Geometric.
Why?
Because it's going up by 3 every time.
It's going up by 3 every time?
Being multiplied by
Yeah.
It's being multiplied by 3 every time. Because 1 times 3 gives us 3. 3 times 3 gives us 9. 9 times 3 gives us 27. So this one is geometric.
Can you just divide those two?
You can. 3 divided by 1 is 3. 9 divided by 3 is 3. Absolutely, you can divide them.
What is 1/3? No, that's 1 divided by.
It'd be 1/3 if it was going in the opposite direction. The common ratio is times 3.
And
Okay.
the last one, none.
Yeah, let's talk about the last one.
Also, you never answered my question. Can it be both?
I did answer your question. Peyton said if your sequence was the same number over and over again, 5, 5, 5, 5, 5, it would be going up by 0 and being multiplied by 1. So technically both. I don't know if you get credit for that. I don't know if a math guru would agree that that was a sequence, an arithmetic sequence. So I know it's not geometric because to get from 2 to 8, I times 4. And to get from 8 to 14, I don't even know what I times by. Like 7/4 or something? 1.75. I know it's not 4. So it can't be geometric. Emily says 1.75. So it's not geometric. Let's check and see if it's arithmetic. To get from 2 to 8, I add 6. To get from 8 to 14, I add 6. Looking good. To get from 14 to 22, I add 8. Womp womp. So this one is neither.
Oh, I just
I
put
put
none.
none.
None is fine. None's fine.
Which none? That's fun.
the one that you want to be.
So it's important to be able to do the two things that we did in these problems. It's important to be able to identify is it arithmetic or geometric, but it's also important to be able to identify what it is going up by every time, because the next thing we're going to do is make some predictions about what will come next. Por ejemplo. And my question is, what are the next three terms? So let's start with the one that we generally think is easiest, which is arithmetic. Is this an arithmetic sequence? Why not?
Because you're adding or subtracting. Wait.
I'm actually subtracting 5 here. 1 minus 5 is negative 4. And then I'm adding 20. I don't need to go any farther to know it's not arithmetic.
But you know it's geometric. Is it geometric?
I don't know yet. We're going to find out. So let's find what it's going up or down by. Let's find our ratios here. Oh, very good. So Abby said, I think you're multiplying by negative 4. If I do negative 4 divided by 1, I get negative 4. 16 divided by negative 4 is negative 4. Negative 64 divided by 16 is negative 4. So this is geometric.
And then the next one would be positive 256.
Oh, spoilers. This is geometric because we have a constant ratio. And what is the constant ratio? Negative 4. And so if I wanted to find the next 3 terms in the sequence, I would just take the number that's on the end, negative 64, and do what with it? Multiply it by negative 4. So let's start with our last term, which was negative 64.
And then it's going to be 2.
And we are going to multiply by the constant ratio, which was negative 4, which will give us, so that's the next term in the sequence. But the problem says what are the next 3 terms, so go ahead, Abby. Good.
Which is going to be negative 1,024.
So I take the previous answer, which was negative 256. And Maddie, could you give us the answer, please?
1,024.
Very good. That's the second number that we need. To get the third number, we take that answer, negative 1,024.
You get 4,096.
All right, hold on. I'm still writing the workout. I'm not ready for you yet. Okay, go ahead, Peyton.
4,096.
Very good. So the next 3 terms in the sequence are 256, negative 1,024, and 4,096. We're just continuing the pattern all the way down.
Is that supposed to be a negative there? 16.
Say that again?
The 16.
1 and then negative 4 and then 16. Is that supposed to be a...
Right, good question. It's not supposed to be a negative because since we are multiplying by a negative every time, the sign flips back and forth. That's a good observation. Because a negative times a negative is a positive, but then we do a positive times a negative, which gives us a negative again. That's why our next 3 terms go positive, negative, positive. Good question. Okay. How about this one? How about I not write in highlighter? Like that. Very good, Emily. The pattern here is that I'm dividing by 3 each time, or you could also think of this as multiplying by 1/3. Either one of those is fine. I'm going to keep it as multiplication because if you're having trouble just looking at the pattern, like Emily just looked at it and said, oh, I can see it's divided by 3. Sometimes that's difficult. It's hard to look at it and just know it's divided by 3. But if you write out our ratios like we've been doing every time, 3 divided by 9 is 1/3. 1 divided by 3 is 1/3. And then here's where it gets a little goofy. 1/3 divided by 1 is 1/3. So this is geometric with a constant ratio of 1/3. Which means I just continue multiplying every single number by 1/3. I still want the next 3 numbers in a sequence, just like I did before. So I'm going to take the last number I had, which was 1/3, and I'm going to multiply that by my ratio, which is 1/3. You may want to use the calculator for this, that's fine, but the number you'll come up with is 1/9. All right, then I'm going to take that number, 1/9, and multiply it by the constant ratio of 1/3, which is going to give me 1/27. Again, if you're not super comfortable with fractions, using the calculator is okay. We'll only shame you a little bit for that. And 27 times 3 is going to be 81, is that right? Somebody check me, I think it's 81.
27 times what?
3?
81, yes.
81? Good. Okay. I knew it all along. So the next 3 terms in the sequence will be 1/9,
So I guess we're much better.
1/27th, and 1/81st. There's our solution. This making sense to you so far? A little? All right. Am I going to ruin it? I hope not. I always try to write in highlighter for some reason. I'm going to give you 2 of these to practice. And just like before, I want you to try to get the next 3 terms in the sequence.
Managing I, and I'm getting on these ones, so.
Yes, yes, ma'am. Neither of these is arithmetic. They're both geometric.
What's the difference between
Hmm?
I just figured out that
We're
I multiplied negative 75 with negative 5 and got 375.
the yeah,
Oh.
you're welcome to say that. Arithmetic, I mostly just wanted to review the term with you. Arithmetic is a little basic for this class because you learned how to like count by fives or count by tens a long time ago. Geometric is the new part.
It's like the.
You typed in 72 routing and it's 75. That's what we're doing last. Well, you'll like it next year. You're about to learn how to do it. It's not that hard once you know how to do it. You
I have
are
no
correct.
clue about that
On
one.
the
I
edge.
just guessed.
Well, the way you figure out what the ratio is you do this divided by this. So that's 15 divided by negative 3.
Negative 5.
And then what's negative 75 divided by 15? And then 375 divided by negative 5. Hey, look at that. Oh. Forgot the 7 divided by negative 75. 375 divided by negative 75.
And then don't you divide 3?
You did 375 divided by negative 5. It's 375 divided by negative 75.
Oh, and then you multiply 375 plus times negative 5.
So, Andrew, you see how your it's negative 5 every time? That's what I'm multiplying by. So to find the next 3 terms, you just take the 375 and multiply by negative 5. That'll give you the next term.
So you go from right to left instead of left to right.
When you divide, yes, sir.
It's called arithmetic. I don't know what I said.
Yes,
You have to find the other these terms. The first 3. Okay, I got all the numbers.
Oh, this is not that. So you do base times height to get the rectangle on the bottom, and then you don't have to treat this like two triangles. You can treat it like one triangle. This is 25, height 7.2. So you do 25 times 7.2. Right, 25 to So, oh, this is going to be the problem. Well, A is going to be the area, right? How much? Oh, it says the velocity is 70.
Stop, Maddie. You're gonna piss me
Oh, I forgot it was recording.
off. Oh my god. It's still recording. It's like, stop, Maddie. You're gonna piss me off. You're the one that bothered me when I'm trying to sleep.
Well, you're not supposed to sleep.
I probably have a better grade than you in math.
Really, what do you have in math?
Mr. Taylor? Mr. Taylor? Do you know my grade in math? It's good though. It's really good.
Yes.
That one I've added, and it'd be 12 plus 27.
Yeah, which means it's not arithmetic.
It's not.
It's got to be geometric.
Do you know my grade in math?
Not off the top of my head, no.
They're both geometric.
It's probably good. Your math teacher's very handsome.
Is it better than Maddie's?
Oh, I don't know. And if I did know, I wouldn't tell you. So I'm multiplying by -5 every time. So if I wanted to find the next 3 terms in the sequence, I would take the last term, which was 375, and I would multiply that by -5. Now you're definitely going to want a calculator here because the numbers get gigundo. Yes?
What if they ask you to find yeah, the 12th?
They will ask you to do that as soon as we do these 2 problems. In fact, they will ask you to do that.
You will ask us to do that?
No, it's they.
It's you. It's negative 1,875.
Thank you. Then we'll do 1875 times -5.
9,000.
Whoops. Hold on, that's going to drive Emily crazy if I don't keep my color scheme consistent.
9,375. They all end in 75.
Well, that's convenient. And then the third sequence will be
Negative
The-
46,875.
like that.
Mr. Taylor, negative.
Like that.
Yes.
So the next 3 terms in the sequence are -1875, positive 9,375, and negative 46,875.
That big number there.
That's
I can.
okay. What about this one?
It's going
That one
by
was overwhelming.
3/2.
3/2. If you did 1.5, that is also totally fine. I got no problem with decimals. So you could multiply by 1.5, which is probably easier to do on the calculator. It's probably easier to type 1.5 than 3/2, but I don't really care. So the next 3 terms in the sequence would be 81 times 3/2. Now I'm sorry to say, unlike the last one, these are not going to turn out quite as handsome.
They're going to be decimals.
3/2 of 81 is going to be a decimal.
16.2. I got 16.2. I got 81 times 1 divided by 5.
16?
I thought you were still.
What's 81 times 1.5? Yes, ma'am. Okay, thank you. Okay, and then I will do 121.5 times 3/2.
182.25.
Oh, sorry, I wasn't looking at hands. I apologize. I was focused on writing. Abby, can you please give us the last one? That is unfortunate. It's a pretty gross number. So our 3 terms are those, that, and that. Okay. We feel okay about those? Because here comes the last piece. And it's a question that a couple of you have asked me already. What happens if, instead of asking for the next 3 terms in the sequence, you say, what's the 27th term in the sequence? Now, one option is I could just keep writing these out, 2, 3, 4, 5, 6, 7, to infinity and beyond, till I get to 27. That's one option. If I said, what's the 5th term in the sequence, that's probably not a bad way to go. Just multiply it out. But if I say, what's the 27th term, I'm not writing that out. I'm going to want to write an equation. And so that is the last thing that we're going to do. Okay, so let me give you a sequence. Yes, Miss Bizzle, Lizzie has been out this week, which is why we're recording this for Lizzie. So if you'd like to say hello.
Okay. Hello, Lizzie. Miss Bizzle.
Okay, so if I were to ask you, for example, to find the 9th term in the sequence, I'm not going to figure out what the geometric ratio is and then multiply it 9 times. Just not going to do that. So I need an equation. Step 1 for the equation is the same as what we've been doing so far. Let's find the ratio. What am I multiplying by every time?
2.
Close.
-2.
-2. So this is geometric with a constant ratio of -2, multiplying by -2 every time. So the formula for how to write this is going to look extremely familiar to you. Extremely familiar because I've shown it to you, something similar to you before. So I'm going to do a little bit of a weird notation. It's going to look a little unusual. I'm going to write the equation first, and then I will tell you what all the variables mean. But this is...
Is that a comma after A?
no, it's a number 1. Is that better or worse? That's worse.
So much worse.
That bothers me.
Because it's like, oh, okay.
We'll do green and red as a pleasant combination. Do big thick letters. Equation.
Ugh.
You're right. That's awful.
No, that's awesome.
That's pretty bad.
That was awesome.
That was very distracting.
Because of the way I drew my Q, it kind of looks like a face sticking his tongue out. Okay.
Meh.
So let me explain to you what the various pieces of this mean. N is the nth term. So for example, if you were asked to find the 9th term, nth, n with a little th, nth term, find the 9th term, n equals 9. A with the little 1 is the first term in the sequence. And R is the constant ratio. So in this problem that I just gave you, let's see if we can figure these out. The nth term in the sequence. Let's just assume that I was asking for 9th term. If I asked you for the 9th term, n would equal 9. The way that you read that is a sub 1. It's called a subscript, so a sub 1. The first term in the sequence, meaning when I wrote it, what was the first one I wrote?
-6.
-6.
What does I stand for?
Means like for example. And then R, the constant ratio, what did we find was the constant ratio for this problem?
Like -2.
We found that it was -2.
And then don't we put that into the graph?
We do. So a sub 9, I'm replacing the n with 9, is equal to -6 times -2 to the 9 minus 1 power. And that can be typed into the calculator.
Question.
Answer.
Can, instead of us doing 9 to 9 minus 1, can we just do it to the 8th power?
Absolutely.
Is this right?
Instead of
So Maddie got negative 1536. Can I get somebody to verify that Maddie's answer is correct? It looks correct on the calculator, but somebody else do it just to make sure.
What'd she get?
What I highlighted right there, negative 1536.
Yeah.
She got right.
Christian got that. Peyton got
No,
that.
wait, actually, no. It is 1536.
Oh.
Because she didn't put in the negative. Because
I think
negative
it
times
should be
negative.
negative. Did you put the parentheses around the negative
No,
2?
she didn't. But it's supposed
Oh.
to be negative times negative equals a positive, right?
Right, but negative 2 to the 8th power means negative 2 times negative 2 8 times. So negative 2 to the 8th power is a positive number. And then you multiply that by negative 6. So now that we have this equation created, it'd be really easy for me to ask you something insane like, what's the 27th term? Now, unfortunately, as you learned with the M&M lab, exponential growth is so fast that if I said, what's the 27th term, I don't think your calculator would tell you the answer. I think you'd get an overflow. You can try it. See if you get an error that says overflow if you do the 27th term. But my guess would be that your calculator can't hold enough numbers to tell you.
The 27?
Yeah, try 27, but it's not going to work.
It actually works.
Oh, really?
Yes, it is. It is.
Is it scientific? Does it have an E on the end? Scientific
Yeah,
notation?
What are you doing? Minus 1. What is a minus 1?
Oops. Let me keep my colors consistent here.
Oh.
Okay, last problem that we're going to do. I want you to practice this one on your own. I want you to write an equation for this sequence. Let's find the 10th term. Let's do this last problem, and then I'll give you a giant pile of practice.
Are you lying?
Well, I didn't get hugged enough when I was a kid, so now I'm angry and I'm taking it out on you by giving you math as a punishment.
Okay, so all you need is a hug and we don't.
I'm just kidding. I got hugged plenty, but I'm still mean.
Mr. Taylor, can you actually
Okay.
like go up on the tablet, please?
I'll tell you what I'll do, Peyton, is that whenever I'm done with this, I'll just email you the notes so that if you missed anything, you can get it. I'll scroll down until the practice is at the bottom. But if you missed anything, I'll email the notes to you.
Okay. You're going to
I know. I'm writing pretty quick. I'm trying to get this done before you start art, so I'm going a little quick.
We could miss a little bit. No, we cannot. You stop it. I don't know if you're right.
I hope we're doing fun stuff in art or something.
Are you done now?
Yes, ma'am.
So instead of 96, 96. Since we
I like that. This is a check of paper. Yes, ma'am.
Wait, did you get this one? Yeah. Oh, can I put it right?
Okay, I will tell her to come back your way right now. Mm-hmm.
Just what I did.
Miss Parker needs you back there because she has an art to go to.
Okay.
Wait,
Yes.
what did you do? Is that it?
Yeah. Are we finished with math if we got this?
I'm going to give you an assignment, but you're finished with your notes.
So we want,
You can put your notes away because we're going to go to art in about 5 minutes.
I guess.
So once I check your answer to this.
Come over here.
What?
Come over here.
No. I
And I'm
remember.
not helping.
He stepped on my foot. What the heck was that? What are you doing?
That's all you do.
Okay, real quick before I stop the video, let's put the answer on here so that Lizzie can check herself. So, Maddie, can you please give me the equation?
Yes. Just give me 1 second. Okay, so So 96.
Well, hold on. Let's make sure.
Everyone
Quiet, please. We're almost finished.
Oh no.
We do a sub 10 because we want the 10th term. Okay.
96 times 1/2 to the power of 10 minus 1.
And you can type that whole thing in the calculator just like that, and the answer will be
0.1875.
Aren't we supposed to figure out what it's going up by?
It is. What is it going up by?
I have no idea.
It's going up by 0.5.
0.5. That's where this came from.
0.5.
96 times a half is 48. 48 times a half is 24. And 24 times a half is 12. Does anybody have any questions?
Can you leave it there?
Yes, I can leave it here. Yes, sir.
Are you gonna give us some to work on later?
Yes.
Stop it. I'll just ask. He's
And-
already gonna do it.
Any other questions? Right, everybody say bye to Lizzie.
Bye, Lizzie!
Get well soon.